This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 141, a look at how Ansys tools can be used in the critical area of robotics, and a look at news and events in the world of Ansys and Synopsys. Greetings, my name is Eric Miller, and I'm one of PADT's three owners and your host for these podcasts. This is episode 141, and all I can say is that the more things change, the more they stay the same, at least in the simulation world. What we're looking at right now is Ansys 2026 R1 is out, and there are some killer enhancements in there. We're super excited about the deep down featured changes and new capabilities, and enhanced pre and post processing, plus the normal performance enhancements that we like to see as far as running faster on different new exciting hardware. The new in this release, though, is more practical AI implementation. So we'll talk more about that as time goes by. But for now, if you haven't looked at what's new in 2026 R1, you should take a look. There's a lot of cool stuff there. And like I said, we'll come back and talk about some of the bigger ones in future episodes. So as far as the merger with Synopsys goes, the biggest change we've seen in Ansys people that they've had their emails go from @ansys.com to @synopsys.com. There's not been a lot. There's been some management changes and teams and people and teams changing, but that is in areas that don't really impact users too much, like marketing and IT. Overall, it's been a really great transition here in locally here in Phoenix. Of course, we're dealing with record heat, and I know some of our customers and employees have dealt with snow and rain, especially some folks in Hawaii. So, stay safe out there. On a more engineering note, there's a lot of technology megatrends out there, and of course, AI has sucked all the techno-oxygen out of the room. But a megatrend that has not slowed down while all this AI stuff is going on is automation, and specifically robotics. So for those of us in the mechanical world, the physical world, this is really important. We're super lucky to not just have one of our in-house robotics experts, Noah, who usually comes to talk to us about that topic on this podcast. So he was on the call, but we're also very fortunate to have three experts from the support team at Ansys. So the Synopsys folks on the Ansys side came and joined us. They're answering questions every day on how to leverage simulation to design better robotic systems, improve performance, enhance safety, and reduce cost. And what we'll learn as we listen to them is we're not talking about just designing and building robotic systems, but actually using simulation, Ansys simulation, while using the robots and improving the performance for the application. Anyway, I'll let them explain. Let's take a listen. It was a great discussion, and I learned a ton. So here we go. I want to welcome everybody to a great discussion today in the world of Ansys, and we're going to talk about a topic that's kind of out there in the world these days because of the dancing robots, is robots. I don't know if we're going to talk about the dancing version of them or the dogs, but we're going to talk about what robots are, and then how we can use them, or how we can use the Ansys tool set to design better performing systems that we would refer to in that category of robots. So let's get started with introductions. I'm going to go ahead and just go down my list. So Dev, why don't you just let us know, your full name and what you do at Ansys?
Sure, Eric. First of all, thanks a lot for inviting me to this talk. It's a pleasure to be here and talking about area that I'm a little bit passionate about, right?
Mm-hmm.
So begin with, I'm Dave Sarkar, and I lead one of the structures application engineering team here at Ansys. I'm based in California, Sacramento, and my responsibility is supporting the customers primarily on the West Coast of the North America. So
Excellent.
good to be here.
Very good, very good. And then Noah.
Hey, Eric. Always great to be on the All Things Ansys podcast again. I'm a application engineer, and Noah Asherbranner, application engineer at PADT. My background is in robotics and autonomous systems, so this is definitely up my alley, something I've been passionate about for a long time. I've been supporting different customers, primarily using the model-based systems engineering tools, not excluding robotics customers that I look forward to talking about, in this call.
And I can vouch that he is into robots. I have seen one go down the hallway here at the PADT offices, so that was definitely kind of woke me up. Arash.
Yeah, hi Eric. Yeah, thanks for having me on this podcast. My name is Arash Hassanpour. I'm a part of application engineering team at the Ansys Synopsys. My main focus is on model-based engineering, engineering, and also system-level modeling
Mhm.
and digital twin. And recently, I've been working a lot on a robotics application.
Excellent. Very good. And then Nicholas.
Yeah, thanks, guys. Thanks, Eric. As Dev said and everyone said, pleasure to be here. Thanks for
Mhm.
having us.
Yeah.
My name is Nick Herringer. I have a very similar role to Dev here at Ansys Synopsys, in that I am one of our application engineering managers. My team's focus primarily on our optics solutions, and I'm kind of here representing robotic sensors more generally.
Mhm.
So that's both the optical stuff and also some of the high frequency solutions that we have. So excited to kind of talk about that in the world of robotics.
That's a great way to get into it because when we think about robotics, we usually think about I mean, for me as an engineer, I think about the classic arm, the multi-dimensional arm that can go and grab stuff and move stuff and do things like that. But robotics is a lot more, and so I'll just kind of throw this out there. Who wants to, talk about? There's that classic robot arm, but what other things fall under robotics? Is a pick and place machine robotics, or is that automation? Who wants to tackle that?
So
I
maybe
mean,
I
I
can
can take us.
Yeah,
go
go
for
ahead,
it,
Deb.
Dev. All you.
All right, all right. So robot, like Eric, what you said, when you think of robot, you basically imagine a picture, a classical robot, 5 or 6 axis,
Hmm.
picking certain things, placing certain things. But the paradigm has changed.
Hmm.
Like in the GTC, Jensen said pretty much everything is a robot. Okay,
Hmm.
a building is a robot because it's doing something. It's like a machine which is capable of accomplishing certain task. And the added functionality right now is the intelligence part. So apart from the classical robot, the 5 axis or 6 axis industrial robot, we have many other types of mechanisms. Like there is a thing called delta robot, which is the shape of the robot is like a diamond shape,
Hmm.
delta shape. It's very common in the electronics industry. And then there are SCARA robots. You might have seen the ones on the 3D printing machines, which goes, like in a Cartesian coordinate system. And then there are, those things, like the mobile kind of, autonomous mobile robot. So basically, imagine things like, a robot vacuum, or maybe, those robots which are operating in the Amazon warehouses. Those are robot. And then exploration, the things that are taking part in mining and industrial inspection, maybe, painting a building. So, it's just taking so many different forms and functions that anything literally that moves, anything that has machine, and anything which is sensing and acting is potentially a robot.
Cool. Yeah, and we call our vacuum cleaner Maynard, and he's old enough to just bang against the wall and turn around when he bangs against the wall. But yeah, he's a robot. You're right. Yeah, exactly. Um, so when we're designing robots, it's great to have people from the application engineering team. So if our listeners don't know, one of the cool things about being in the application engineering world is you get to see all these different industries having all these different challenges they need to solve, and you get exposure to them. So in the world of robotics today, what are some of the challenges they're facing, and then maybe how does kind of simulation help with that? I mean, I assume structural, you mentioned sensors, there's lots of stuff out
Yeah, I think
there.
there's
Yeah.
different categories
Hmm.
of this. But at least where I've spent time working with customers, on the kind of sensing side of things is kind of handling this feedback loop with any sort of autonomous system. It has to have the components, right, that make up the actual physical robot, but then it also has to have the sensor platforms that can interpret the world and figure out what am I looking at, or are there other components or objects or people in my near proximity. I don't want to collide with them. Right. And then there's the aspect of getting that sensor data onto a compute platform that can process it and make a decision. And I think that, particularly when you talk about the concept of digital twin and safety for robotics and autonomous systems, you start layering all these different aspects on top of each other, and it's a very complex multi-physics problem. So maybe at the core of it, kind of what I've seen is that customers will want to do a thermal simulation with an optical simulation, or a structural simulation with an RF, or some other sort of motor simulation, for example. And just combining the physics at that level is one aspect, but then the other is, okay, what do I actually, or how do I handle making the decision and training a robot so that it can make the right decision before we deploy it, and managing, what can I do in simulation, what could I have to do with physical test, and making those trade-off decisions for economy and scale and safety.
Very cool. There's a couple of those I want to dig into, and I'll come back to them. But anybody else have any comments on kind of their view, what they're seeing out there, the challenges that customers are facing in getting their robotic systems up and running?
Yeah, sure, Eric. One of the challenges is how to bring all these different physics together and see the interaction between different physics. So if we model every part separately, we may miss some of these interactions. But looking the robot as a system and how to connect all different analysis, sensor, mechanical, electrical together is a challenge. And without that, we may not have the accurate understanding of robot operation in real world.
I guess that's really the point, is these devices operate in the real world, so you can't just say, I only care about the motor performance, right? Or I only care about the this actuator or the stiffness of this boom arm. You care about heat, you care about RF, you care about I guess CFD even, right? If it's got some sort of a fluid flow in and around it, you care about that too. Yeah. Interesting.
Exactly.
Yeah. Yeah. Good. I want to dig into something that Nicholas mentioned about making sure the robot's performing correctly before you actually build it or deploy it. And, in my mind, because I'm a simulation person, I think you should use simulation for everything. But are customers using a digital twin of their robotic system to program it and make sure it's working correctly before they deploy? Is that something people are starting to do now?
Yes, yeah, we see that increasingly more in industry that people want to train or test their robot and their learning in a virtual environment. To do that, you first need to have a physical model which is fast enough that can be run in real time or near real time to be able to perform lots of different scenarios to be able to train the robot. And our tool can help customers to create that digital twin of the robot and accurate physics that predict the right behavior, correct behavior of this robot in a real world environment. And we can also connect that to sim-to-real platform like Isaac Sim in order to help customer testing their policies and training the robot.
Very cool. So it is happening. That's good to hear. That's good to hear. Yeah, the other thing that when we're talking multi-physics is the actuators in the robots themselves. I would imagine that like MotorCAD or Ansys Maxwell. Anybody can we talk about how any of the robot manufacturers and designers, are they doing a lot of simulation on the magnetic side of things, and how's that benefiting them?
Yeah, I can comment on that. So electric motors and actuator is a important part of any robot.
Right.
And for majority of robots, you cannot go and buy off-the-shelf electric motors. It needs to be designed specifically for that application. It needs to be in a certain size and shape and certain performance to be matched with what robot needs to do. And for that, it's important to customize the design. We have the best class tools to design electric motors. You mentioned MotorCAD and Maxwell. And we have many customers in robotics application who use MotorCAD and Maxwell to design actuators and electric motors for their robots.
Yeah, cool. I think I even saw somebody using it to, was it ZMax to do the optical encoder for a robot. Very cool application when you talk about multiphysics, right? So, yeah, very, very cool. So, we talked about joints. We talked about, I think everybody our listeners kind of understand the structural side of things. But a tool that I like a lot, but I never get to use enough, is Ansys Motion. Are customers using that are they using it as a digital twin? Are they using it to get loads? How would one use Ansys Motion for a robotic application?
Maybe I can chime in on this one, being the structures person.
Yep.
Yes, so Motion is the flagship multi-body dynamic tool in the Ansys portfolio, and with that, it fits very nicely for robot simulations. Okay, so many of our customers who are either robot manufacturers or they are using robotics for some industrial applications, they are actively either investigating how to utilize Motion for their workflows, or they are already Motion customers. So what are the different ways that they can use? The classical trajectory planning, that is one of the applications. Okay, so for that, one of the technologies is inverse kinematics, which is something that you can do with these multi-body dynamics tool. So understanding how the end effectors of the robot move, or what it needs to take the end effector through a particular trajectory, right? Sizing the motors, while you ask the robot to perform a variety of function, what kind of joints, torques, and forces are subjected to. So based on that, we can have the motor specs, right? And also Motion has the ability to like model stiffness and other flexibility at various locations, and the members, the arms. Because of that, you can predict the stresses and deformation on the various flexible components. Motion is also used for setting up the system level model. So Arash was mentioning the actuators, electrical actuators and the control. So Motion has the ability to, be part of that closed loop control system, and hence being able to evaluate something on the system level as well.
That's really good to know. So you can hook it up to your control software and deal. So yeah, in before you even build anything, which we love. We love
Yeah,
that.
yeah. It's super interesting because that way you can track if the control is doing the right thing or not. Because imagine let's say a robot which is carrying a container with liquid inside. If the robot arms move too quick, there's a potential that the liquid might spill. So you want to make sure that the velocities and accelerations, they are within the limits. And that type of calculation is only possible if you have the control system in place. So not only Ansys or Synopsys tools can be used, but motion can be also plugged in with things like Simulink.
Yeah, I love that. That's fantastic. So, one thing when I was researching this that kind of surprised me is there were a couple of applications of LS-DYNA in this world of robotics, and so I don't know if any of you have experience with customers using LS-DYNA for robotics, but I think it was some pretty sophisticated impacting that was going on, and they needed to understand what the loads were in this very short impact period for, I think it was riveting or something. But anybody have any stories or anything they can share about doing that explicit dynamics structural simulation for robotics? Is that one you guys haven't run into yet?
Well, very limited applications on the Dyna side of the things. It is primarily a multi-body dynamic simulation from the structures point of view.
Right.
But Dyna is potentially useful in, one of the application, which is cobots. Okay. So cobots is, and one of the customers actually showed interest in that. So when a moving object hits a human in vicinity, which is something cobots are being used everywhere. So robots in vicinity of other robots and human beings as well, right? So in LS-DYNA we have these Hans human models, and one of the interest areas to see how the robot arms can impact human bodies and potentially cause some injury, right? So that is something of interest. Also, one use case is, for example, in warehouses. So if the robot end effectors are interacting with soft objects, maybe a package, maybe a, cardboard object, So the interest is to see if that can create some kind of failure on the object being handled.
Cool. I love that. Um, so
And one other
go ahead, please. Yeah.
That's kind of interesting there with the with Hans that Dev mentioned, and maybe a system that's not traditionally thought of as a robot, but I think truly is autonomous vehicles.
Valid point.
Right.
Yeah.
So, with respect to crash and safety, Dyna is often used, to do these kind of simulated crash tests because you don't want to put a person in a car that's crashing. Right. So that's another area where certainly we see it, but of course this is blurring the lines between, kind of maybe what people think about robotics and our more traditional automotive customers.
I love that. And I refer to them as autonomous vehicles, but a friend from out of town was like, what are all these robot cars doing in the middle of the street? And I thought, oh, wait, that's what people think of when they think of these Waymo cars. They're robot cars. Yeah, it's a really valid point. It's really, really good. We haven't really talked about model-based systems engineering. And so I don't know if you want to take that or somebody else, but where does that fit into designing and improving the performance of robots?
Sure. I mean, the robots that we're designing will have a lot of different requirements, whether they're, kind of at the level of who's designing the robots, or if it's for the customer who's using these robots in their different, workflows, whether it's, kind of production line industrial, whether it's delivery robots, or anything in between, right? And you want to have confidence when you go to market that your system is going to check those requirements. And that's something we're starting to see more and more as time goes on, right? These are getting more and more complex. And so wanting to keep track of those requirements and how you're meeting them is becoming more important every day.
Yeah. Good application. Yeah, we tend to get into the weeds and forget about that system level important things. And we won't talk about it here, but I'm sure that the Ansys safety software tools are also applicable in this industry to make sure you're not missing something from a safety standpoint. But what tool set did I leave out? I kind of, we mentioned fluid in passing. Of course, there's fluids. We can model that. We can do optical sensors. We can do high frequency electromagnetic sensors. What else would we talk about using in the Ansys suite for a robot? Or we get them all?
There are a few things that I can imagine, and I have seen the requests coming through.
Good.
Robot uses a bunch of cables. There is some, there's something going on. There is a signal transmission, there is a current transmission. So there was a request of, like there is a product called EMA 3D, for example. So how can we, do that type of calculation in the robotic space, right? So that becomes super important. The second is obviously, and Nick can speak to that more. There are just antennas and sensors everywhere, and we have a suite of tools that can, make sure that there is a limited interference or the signals are not getting affected by the noise. There is enough isolation between. Maybe Nick, you can, add your comments here.
Yeah, these are, a lot of this falls in the optical and RF spaces. And I think if you look at each of these individually, it's kind of a similar story in terms of what people and our customers really care about. And number one is, one category is kind of the component level simulation, which is all relatively straightforward. It's generally single solver or a couple of very adjacent solvers that you're using. In the optics realm, I describe this to my customers as like the test bench setup, where it's a very controlled environment. But then the other category of simulation, which we've touched on, a few times, is more that system level. And there, it's again maybe two subcategories, at least how I break it down for myself, is customers want to understand how their system is going to place itself in the environment. So that would be integrating the sensor packages or sensor components onto kind of sensor packages onto the robotics platforms, and placing that whole system in, say, maybe a static environment, just to get a reading of, okay, where am I as the robot? But then the other thing is using those sensor simulations to kind of predict, okay, how does this robot actually interact with the environment, whether that's say an autonomous vehicle, weather conditions changing, or say a warehouse robot moving around, lighting coming on and off. If you have optical sensors that are visual, that can make a big impact. If you have heat for thermal sensors, all the interference, it's one level of figuring out, okay, where on a given robotics platform should the different RF sensors be placed so that you can get an accurate reading of that isolated robotic system in an environment. But then the other is, if again you're in a warehouse and you've got dozens or hundreds of these things moving around, you need to simulate each of these and make sure that interference from one robot or sensor platforms on one robot are not interfering with sensor platforms on another. And it just gets exponentially more complex the bigger and bigger you go. But these are kind of the stacking layers of complexity in this space.
That's really, yeah. I love that because, I think I kind of came to this of, my early days of a robot was kind of a dumb thing. You programmed in a set of motions. You hit a button and it did those motions, and it may not even have a sensor to tell if it hit something, right? And now they're smart. There's multi-physics, and they're part of a system, yeah.
And this is one thing that I don't know if any of us here on the call are particularly equipped to answer this, given our relative novice status as members of the Synopsys environment. But I think that chip design, custom chip design, plays a very important role in robotics today, and will play an increasingly important role, as this transformative technology of AI and physical AI for robotics builds on itself. Right? There will be, very specific needs for different applications of robotics, whether it's healthcare or autonomous vehicles, as we described, or defense. And there will certainly be, needs for custom silicon incorporated into those systems. And yeah, maybe we could have a follow up and have some Synopsys folks, legacy Synopsys EDA folks, to be clear. Maybe talk about that. But something I'm curious.
Silicon to systems, right? A robot really implements that, right? It's a multi-physics system that goes all the way from down at the chip level all the way up to a very complicated system. I love that.
Yeah. I think robotics tells that story perfectly.
That's really. Go ahead.
I think one other area where we're kind of seeing this, right, is as robots are kind of becoming more prolific in our own lives, right? You're getting to see more applications where there's some level of safety criticality, whether it's the collaborative robots where you're working, side by side, or if you are looking at autonomous vehicles, right, where you've got passengers inside and have some concern of the safety of said passengers, right? And so thinking about the software that's running under the hood and meeting safety requirements and understanding that it needs to behave a certain way when it's within some proximity of people or have people around it on the road, for example. That's increasingly important, and you don't necessarily think of Ansys as necessarily fitting that mold too often, unless maybe you're in the aerospace background where you might be familiar with a tool like SCADE. But having that confidence in your embedded software is certainly important in this sort of realm as well.
Yeah. That's so true, and especially as the performance goes up, and we talked about cobots, and I guess autonomous vehicle is the ultimate cobot, right? So and we can't forget our flying cars, right? So a couple Ansys customers are starting to test their autonomous VTOL aircraft, electric VTOL aircraft, and using Ansys throughout those robotic flight systems, right? Quite exciting stuff. Wow. So we're just opening up the topic to more and more, but we like to keep these around 30 minutes, so I'll kind of wrap it up. But one of the things I always like to ask is if an engineer calls you guys up and says, my boss just told me I need to model this. Let's just keep it simple. Let's just say it's a warehouse mobile robot that just kind of goes over. It's a forklift on wheels that goes and picks stuff off shelves and puts them someplace else. What advice would you give them on what they need to think about when they're applying these tools? And we're talking things like boundary conditions and loads, and what kind of sage advice for a simulation engineer would you give if they're doing a robot? What's unique about robots?
My advice would be to start simple, because any of these robots are so complex. There are multiple branches of engineering which is going into these systems. Potentially we can use 10, 20 tools from our portfolio. So there is no limit to how complicated that can be. So I think my advice to all the customers that I have dealt with is start very simple. Most of these robots can begin as a simple, kinematic chain, like a simple mechanism. And then as you show interest in certain areas, let's say you are trying to work on the controller. So maybe you can start putting that element. Maybe now you are curious about the sensor, then you can put that element and you start building model from ground up. And system level model is something that you should not be doing from the get-go. Right. Because you have not yet validated your structural components, your electrical components, your optical components. So that has to be kept for the last, I think. And another interesting thing is that in Ansys, there is always a range of fidelity for every tool. So you can make the simplest model and you can make the most complex model in every physics. To give an example, in electrical world, you can start with RM Expert, 2D level tools, and then you can go to maybe 3D level tools, right? So start simple and start putting elements as you need, go up.
Yeah, that is a great good of a suggestion for all simulation, but I think robotics especially, you can get really wrapped around the automated axle, I guess. If you don't be careful and don't jump too fast into things. All right, anything that we didn't talk about before we wrap up that any of you want to say about robotics and Ansys simulation?
Yeah, the one thing I would like to add, and this is coming in picture quite a bit because of all this omniverse and all those talks, right? So there is a range of simulations, that are of interest. Uh, but you can see that the industry is mostly talking about the training of the robot, okay? And training of the robot is a completely different ball game. I think there everything happens lightning fast because the simulations has to be done at a speed of 1,000 to 10,000 hertz. You need to know uh, the action to be taken at the next millisecond or maybe even finer interval, right? So training a robot and acting based on the sensor information. So that's a different game, and you typically need, very fast models. And we do have those things, but also there is a need of very high fidelity model, whether it is, trying to diagnose a problem. Maybe there is a field failure. Maybe there is a bearing which is causing too much of noise, or there is a local failure somewhere. So it seems there is a range of simulations that are still valid. The slowest one are the high fidelity one, which is used for a different reason, different purposes. But then there is a need for very high speed simulation. It may be for initial kind of design and iteration, or maybe you need it for training, or maybe it is for what RCU was telling, embodied intelligence. So you have a robot model and is gathering sensor data and is trying to act on that data. So you have to be super fast. So there's a range of simulation essentially.
That's great. That is a perfect place to stop, I think, because I think one thing hopefully everybody's learned listening is that these are smart multiphysics systems and components, and so that's kind of a perfect fit for the Ansys suite because we kind of cover that whole spectrum, both within a given tool. We can go very detailed to high level. We can create reducer models to feed into other things. We can make them all talk to each other, and use the virtual prototyping and digital twins and things like that to get to market faster and improve the performance of your robots. And I don't know how much that's going to help them dance better, but hopefully it'll help them be safer. And I think that's a big takeaway for me is I need to think more about safety and also perform better with greater robustness and higher speeds and performance. So I really appreciate your time. It's always great when we have Ansys folks on the Ansys Synopsys folks. It's going to take me a while. Ansys Synopsys folks on the call, and I found this really informative. You really kind of changed my way I look at this area of simulation. So I really appreciate it.
Thank you, Eric. Great to be on.
Yeah, thank
Thank
you,
you,
Eric.
Eric.
Yeah, thanks a lot.
Everyone.
It was a pleasure.
I hope you enjoyed that as much as I did. Fundamentally, if we really look at it from an engineering perspective, robots are mechanical machines with structures, motors, sensors, electronics, and everything else a normal machine you have. So the difference is they're controlled by software. Right? That's, I guess, what makes it a robot. So Ansys has so many tools that are useful for making robot systems better, from the component to the system level. And that even includes something like Ansys SCADE to take a look at that software that controls everything. So if you are designing or using robots, even just as a dance partner out there, reach out and talk with your Ansys support provider to see how you can leverage the software more to make these products better and perform better out in the field. So, and on that note, I would like to claim credit for not once, I don't think, mentioning our future robot overlords. It would have been an easy joke to throw, but I didn't do it. And more seriously, as a lifelong sci-fi reader, I grew up, I got hooked on sci-fi reading the Isaac Asimov robot stories, especially Caves of Steel, which I highly recommend you reread as an adult. I reread it, and it's still a very good story. And coming from that background, coming from that as a child, really, I find this real world merger of mechanics, electronics, and AI fascinating. He had to invent the positronic brain to do the things that we're now doing with, AI and edge computing with AI, not necessarily in a data center, right? So it's very interesting times indeed to see the sci-fi turn into reality with humanoid robotics as well as very sophisticated automated systems like, robotic cars, right? Autonomous vehicles, as we talked about. So it's very interesting and fascinating, not just from a simulation standpoint, but as somebody that grew up on sci-fi. I love it. It's great. I was trying to think of a tie-in, a transition, I guess professionals call it, for this episode to the commercial. Some way to go from robotics to what I want to talk about. I got nothing. I guess I'm not a professional. But here I'm gonna try this. Robotics is a lot about system level simulation. And one of our favorite system level simulation tools that we almost never use in robotics is FloNex, which is a thermal fluid systems. So you probably know that besides the Ansys, now part of Synopsys product line, PADT also sells and supports another simulation tool, FloNex. So FloNex is a 1D thermal fluid solver that models complex systems with ease. PADT has been a distributor of FloNex in North America for over 11 years now, I think. And FloNex has been a partner with Ansys for just about that long. Our customers use FloNex to model nuclear facilities, mines, secondary flow and turbine engines, combustors, medical devices, and chemical processing equipment. Every month, we find a new application for this really powerful and easy-to-use tool. Oh, and not only are they an Ansys partner, you can connect Fluent to Ansys products in co-simulation or to send boundary conditions back and forth between the two tools. So it's also highly customizable. It's what we do a lot for our customers. There is way too much to cover in this short ad, but if you're looking for a system-level thermal fluid tool, we can say that FloNex is by far and away the best one out there. So visit www.padtinc.com/FloNex. That's FLOWNEX to learn more, or contact us at info@padtinc.com, and we would love to talk. It's our second favorite software tool in the world after, of course, our favorite, which is the whole Ansys suite. And I'm not just saying that. So let's move on to news. Synopsys stock. Well, it's not great right now. It's Thursday after the market closed. It's sitting at 401.95. That's on 3/26/2026 when I recorded this. So it's down 10% since a year ago today. And the big climb, right after the Ansys merger, they got up to 650. So it's down to 401. You can kind of see that Wall Street's waiting to see what's going to happen. They really haven't come back from that big drop in early September last year. So to compare, the S&P 500 is up 13% over the last 12 months. So that's even with the drop we're seeing from the conflict in Iran and the whole oil thing. So it's as I said, if you listen to these podcasts, I don't understand Wall Street. I don't know what's changed. I guess somebody that's part of this, stock market club said, "Ooh, let the price go down," and it went down. I don't understand it. I think the company's performing pretty dang well. Anyway, the Synopsys folks did release their Q1 numbers since our last recording. So if you remember, with the transition, we not only got a transition of names, we got a transition of when the year starts. So for the Synopsys folks, the year starts, and now the Ansys folks, on November 1st. So their first quarter is November 1st through January 31st. They had such a big number, $2.4 billion in quarterly revenue, and they had a small profit, $190,000 in profit on $2.4 billion. So that's, I'll do the math for you. It's 0.3% of revenue. So, it wasn't a super profitable quarter. That's probably what Wall Street's responding to after such strong profits as they absorb Ansys. There's some costs involved. So, they still have a plan to do $9.6 billion for the year, and they did mention in there, they don't always break out Ansys stuff, but they did mention that they expect $2.9 billion of that to be from Ansys products, and that's 30% of the total. So they really have some big plans for the Ansys folks and the products. They also announced during that meeting, they authorized a $2 billion stock buyback plan. So one of the things they're trying to do to get that price up is to, take some stock off the market. So, and one issue, there's not a lot of detail there, and I could probably dig deeper, but I didn't really have time, is that there's a lot of one-time costs with the merger that they had to absorb in that first quarter. So I think that's part of it. One of the things I really like to look at, if you've listened to the podcast for a long time, that really impacts us users is they have a lot of cash sitting around, right? Cash allows them to buy other companies to add to the portfolio, allows them to spend money on R&D. So we'd like to see a big cash. And yeah, they got $2.2 billion in cash. Interesting thing is they've got $10 billion in long-term debt. So that seems like a lot, but if you look at it, it's down $3.4 billion over the quarter. So I don't know what they're doing with the debt and the cash, but they've got under control. So it's coming down. The debt is coming down, and the cash is going up. Their next investor earnings call is May 20th, and we should certainly hear a lot more as they swallow. I always think of a snake swallowing a mouse, right? Sorry if you're a vegetarian. But if you're from my generation, we all had like pet snakes at some point, and we got to watch them swallow the mouse. And I think that's where they are with the Ansys thing, right? Is they've got some costs associated with the merger, and they're working through that. So we'll see when the next meeting is. So after May 20th, the podcast after that, we'll talk about it. So in other Ansys news, the Ansys news page has pretty much not been updated anymore. So don't go to Ansys News anymore. Go to the Synopsys news page. And if you look at stuff about Ansys on the Synopsys news page, you will see that the big news is that 2026 R1 has been released. I really recommend you take a look at it to understand. So this is very public facing, right? This is their goals and their focus on what they want to do with Ansys. So the Ansys product line. So it's really good to take a look at it. And they called this release a re-engineering engineering. And they really are stressing AI-powered products in this. So the 3 takeaways that they actually put into the press release that are probably worth just reading right here and right now. So if you take anything away, this is what they want you to take away, is that this release delivers unified Synopsys Ansys workflows that bring together previously separate engineering processes to create more cohesive and efficient product development. I'll talk about that. The second bullet was advances generative AI and first agentic engineering capabilities that speed design, exploration, automate processes, and enable faster system-level insight. So this is their AI announcement. And it enhances system-level engineering with expanded digital twin capabilities and connected modeling workflows that deliver deeper real-world insight across complex systems. So again, that emphasis we've seen for a while, even before the merger, on systems level simulation, is really, really important. So where are they connecting? They talk about how these tools are connecting. So I don't actually know these tools, but there's a tool called Synopsys VC Functional Safety Manager, which is, by the name, I'm assuming is a functional safety tool. And they're connecting that with Ansys Medini, which is the Ansys safety tool. So good to see there. Also, great to see that the Quantum ATK tool is now connected to Ansys Granta. So the show property capabilities are there, which is a great win for Synopsys users. And also Ansys Lumerical, which is, of course, does a lot of things on the quantum and light physics simulation. They've they've connected that to OptoCompiler, which is the Synopsys tool for doing electrical systems. So good to see that. The other thing they did is they've connected Ansys SCADE to the Synopsys TPT tool. That's a tool for doing electronics test automation. When you do all these electronics, you want to test them. That's their tool to kind of design and monitor those tests, and it's a great fit for doing hardware in the loop with Ansys SCADE. So really excited about that, to see that. And then they shared a lot about where they're using AI, and it's too much for me to talk about here. So I really recommend that if you care to go into and you really want to know what the Ansys Synopsys strategy is, at least publicly, I recommend you read this press release. It's really good. It's really well written. It's very comprehensive. It's technical. So if you search for Synopsys launches Ansys 2026 R1, find the press release, not what the analyst said, and give it a read. It's on the Synopsys news page as well. So I highly recommend that. So other news of that $2 billion that they authorized for buyback, I think they're doing well. So they went ahead and did a $250 million accelerated share repurchase. So I guess that's an eighth of the $2 billion. So that's good to see. They're really investing in that. You can also read the Q1 results like we just went over. That's in the news as well. PADT news. So I've got some great news to share. I'm really proud of our team. So we're all very proud of our team right here. So the big news for us since we last talked is that Ansys Synopsys had their first joint sales kickoff meeting. And that's when they fly all the salespeople and some of the technical people all to one place to talk and learn about strategy and things. And they hand out awards, and one of the awards they hand out now is the America's Customer Loyalty Award. So for the Ansys product line. And of course, there's one for North America. I mean, there's one for other parts of the country. This is the Americas one, so North and South America. And guess what? We won it. So our technical support team, who are often on this podcast, got that award, which we're really, really happy about. So that's a big deal because it reflects the most important thing for how PADT sets itself apart in this Ansys world. And that's the quality of our support and our support engineers and our technical knowledge and our ability to help you with it. So if you listen to this podcast, you get a taste of that. You get to hear our guys talk and what girls talk. And it's amazing what they can do. So, if you're a customer, we want to thank you for liking us enough to rate us well. One of the problems we have with these kind of contests, it's really not really a contest, but data collection for these kind of awards is most engineers don't take the time to respond to a survey unless something went wrong. and we got very few of those. But we do take them very seriously. But what we really like is when people liked what we did and they let Ansys know. And they did this time. So that was a big part of the score and why we did so well. So we want to thank you guys for doing that and letting people know. And, having happy customers is the most important part of receiving this award. We couldn't be more proud of our team. They really work hard at this. They love their job, but they had to work hard for this. They had a lot of tech support calls and really being there for our customers. Something we talked about on the podcast before that really is landing well is, when you call us for support, we don't just log it and get back to you. We're going to try and find a workaround for you so you can get busy, get back to work right now while we work the long-term issue and understand root causes and give you something that you can run with. And so it was great to be recognized for that. So congrats to Ted Harris and Doug Otis, who lead that team and all the engineers on that team. So good job. All right. So on the Ansys blog, on the Ansys website, most of what's on the blog since the last time we talked is some really good articles on 2026 R1. So find your product of choice, read the article. There's videos. Yeah, that's a great way to figure out what's new and different and what you need to know about. I picked two other things to share. One that I really liked was called Harnessing the Power of the Sun with Digital Engineering. So it's doing the system level simulation for Fusion. And I'm a big Fusion fan. We're getting really close. And I'm really excited to see more and more of it. So it's a great article about how people doing Fusion are using Ansys. And everyone is talking about data centers today, right? And how they will suck all the power out of the universe. They're going to be these giant energy grabbing black holes. But, we're engineers, right? We understand that it's more complicated than that these are complicated systems and they can use a lot of power and they cannot use a lot of power. And we can do all sorts of things to make them more efficient. And the article that I really like, Meeting the Energy Demands of AI Data Centers, really looks at how we can use simulation to reduce the consumption of power at these things. So instead of throwing power at it, let's make these things more efficient. And that's everything from power management at the chip level, which we used to with Apache products, and now we do with the Apache product line as well as the Synopsys product line, all the way up to using CFD for the entire data center, or making the heat pumps more efficient, or making the turbines more efficient, and the heat transfer at the chip level, at the component level, at the rack level, at the whole data center level. So very cool stuff. Really cool stuff set upon. Really important that we pay attention to it if we want to get our AI as efficiently as possible. So definitely check that one out. On the PADT blog, we had two articles worth mentioning. One is a look at heat transfer coefficient values in Ansys Fluent. So Tom, who's been on our podcast, got a tech support call, and I thought the answer was important enough to kind of turn into a blog post and take a look at that. So, take a look at that if you're doing heat transfer with Fluent. And then one that we always like to share is that since we last talked, we had Pi Day, so 314. And we celebrate Pi Day every year with pie. We get pie from a local bakery. We do a math contest, and if you read the blog post, which I highly recommend, about PADT celebrates Pi Day 2026, you'll read about my AI faceplant. for Pi Day. So take a look and let us know what you think. So let's go ahead and open up the PADT website and take a look at what's going on with our events. We've got a busy schedule coming up. In the past, we're out visiting customers. If you get our newsletter, which we highly recommend you do, you'll see we're starting to put pictures in as we travel around the Southwest and visit our customers and getting pictures with them. So we enjoy sharing that quite a bit. But what's coming up, if you go to the PADT website like I'm doing right now and go to About Us and then go to Events, you can see. We've got a whole bunch of Ansys webinars we're promoting, so please take a look at those things. The next big event we have, if you're in Arizona, you should know that we're having our first ever AZ Tech, I guess it's Arizona Technology Week, which we call AZ Tech Week. And so that is a statewide week-long event, kind of a decentralized, they call it, event. So everybody's doing their own events. PADT is hosting two really important ones because they're focused on what's needed in the ecosystem, which is mentoring and more hardware focus. So the first one we're hosting is called Advice for Startup Advisors, and it's a breakfast on that first day, the 6th. And so if you're listening to this and you would like to know about mentoring startups or are already mentoring startups, please come to that. It's going to be a fun event. And then on Tuesday on the 7th, we are hosting called Arizona Hard Tech. It's not the same. If you live in the startup world, you know that software companies get all the attention. Hardware companies do a really good job of, over the long run, being a good investment, but they don't get a lot of love. So we're partnering with our local favorite incubator, the Center for Entrepreneurial Innovation, CEI, to do a morning of discussion on this topic. So it's 8 to 12 at CEI at Gateway Community College. And we're going to talk about simulation because, of course, we're going to talk about the Ansys startup program and how simulation can drive getting to funding faster and getting to your prototype faster. These things are all important in the hardware world. And then we're going to talk about funding in general, and we're going to talk about kind of the emotional journey of doing a hardware startup. It's a little bit different than a software company. We are also sponsoring, we're very proud of this. We're sponsoring a STEM event that's part of Tech Week. It's called the Research and Innovation Expo. It's a big, basically a science fair. It's for kids 2nd grade through 16th grade, so basically undergraduates in college. And we're the award sponsor for that. So we're really proud to have paid for the little statuettes that people are going to be wearing. So definitely check that out. We will also, if you're in the additive manufacturing space, we will be both in the Oryx booth, which is a PADT subsidiary, and in the Rapid Fusion booth, which is a 3D printer that we sell, at Rapid TCT in Boston this year. So that's going to be April 13th to the 16th. So stop by and say hi there. At the same time, in Colorado Springs, we will be back at the 41st Space Symposium in Colorado Springs. I love that event. I know many of you who listen to the podcast because you stopped by and said hi to us. Go to that event. Please do that again. We are in a bigger, better Arizona booth. So PADT for a while now has been sponsoring an Arizona booth. We've passed that off to Arizona Commerce Authority, and they're actual professionals. It's a really cool booth. Jeff Wells, who many of you know, will be there representing us, some of our engineers and salespeople wandering around. So that's the 41st Space Symposium in Colorado Springs. That's also April 13th to the 15th. I unfortunately this year won't be there, but stop by and say hi to Jeff. And then we also have an event in April. We're going to the Nuclear and Emerging Technologies for Space, the NETS convention at the Daytona Convention Center. We're going to be talking a lot about FlowNex and Ansys simulation for the nuclear industry. If you don't know, we have quite a few customers in the modular nuclear reactor space, and our local APS, which runs the largest still running nuclear power plant in the country, Palo Verde, is a customer as well, and we do simulation consulting for them. So we love nuclear, and we'll be there talking about safety. We'll be talking about cooling. We'll be talking about life extension and structural simulation as well. Really cool stuff. Sorry about that. Then another really important event for the Arizona ecosystem we'd love to have our Arizona listeners come to is the 2026 Arizona Manufacturing Showcase. That's going to be on May 13th at not Gateway. It's going to be at Grand Canyon University, GCU. at the Lux Manufacturing Space in the afternoon of the 13th. And it's going to be a big, basically a trade fair for manufacturing companies here in the state of Arizona. We're really excited about that. We'll be at the E-Mobility and Clean Energy Summit. Another big use of simulation is in that space. We'll be at the June 18th one, which is going to be at SkySong in Scottsdale. And then finishing out, what I got on here is we're going to be at the Southern Arizona Tech and Business Expo on the 21st. And also very, very important, I skipped this one, is the Arizona Aerospace Summit. We changed the name, so I forgot about it. So this is another Arizona event focused on aerospace. This is going to be defense, aerospace, and space, just aeronautics and space. It's always kind of difficult to categorize those, but things that fly through the air and space. And this is a premier event for the state. This is where everybody's going to get together down in Tucson and talk about aerospace. PADT will have a booth there. I'm running a couple panels, and I believe you're going to talk about simulation because it's really important with some of the defense and commercial space goals that we have in front of us. We're not going to get there without it. So that's it for events. That went kind of long. We got a lot going on, I guess. And that brings us to the end of the podcast. So once again, I really want to thank everybody for listening. It means a lot when we go and we check and we went, wow, there's a lot of people that downloaded this and listened to it. So do subscribe, do like us, do share us with your coworkers. We'd love to get more listeners, spread the word out there. If you want to, stay in touch with what PADT is doing other than the podcast, please subscribe to our newsletter. It goes out to about 40,000 people every month. And there's a lot of good information in there, including a lot of Ansys stuff. So www.padtinc.com/opt-in. Please do take a look at that. And like I said, spread the word and don't hesitate to reach out if you have any questions. Thank you for joining us for the All Things Ansys podcast, episode 141. As a reminder, this podcast is not affiliated in any way with Synopsys, and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.